See students, we have learnt about the circle and secant, about the tangent. Now consider this is a wheel of a cycle. So this wheel runs on what? On the floor. So when it runs on the floor, consider this is as a tangent for this stick. Okay, see, if I put the floor like this, then only it can run. See, if I come to in the same direction, it will become secant. So I have to put like this, then it will become the tangent. These are all radius of the circles. So when radius of the circles are there, how should be the tangent? Tangent is always perpendicular to the radius. I will show in another way. Wait. See, this is the tangent. I will draw like this and consider this as the radius of the circle. This as radius of the circle. When I keep this exactly 90 degree to the radius, then we can have the tangent at this point. This point is called as point of contact. If I write the radius here, if I take the radius here, I have to put this tangent like this. That means it should be perfectly 90 degrees. See here, it is perpendicular to the radius. Again, if I take the radius like this, again I have to put like this. So if I take like this, this is the radius because this is the center point. So I have kept my hand there. I have to keep this like this. See, if I change the direction, it will become secant, or it will become chord, or it will become the diameter of the circle. But to become the tangent, it should pass only one point of the circle, then it will be perpendicular to the radius. This is one of the property of the tangent. That means all the radius, see, this is the center point, this is the radius, from here to here it is radius, it is the tangent at the point of the contact. At the point of the contact, the tangent should be perpendicular to the radius. This is what one of the property of the tangent. Now we will learn what? One basic theorem regarding this. So this is called as theorem. The statement says that the tangent at any point of the circle, the tangent at any point of the circle is perpendicular to the radius through the point of perpendicular to the radius through the point of contact. Through the point of contact. This is the statement of the theorem. Now we will prove the theorem. See, first we have to write the data. What they had given, the tangent at any point of the circle, that is given. So here we had taken a circle. I know this is not perfect circle, but I have drawn by hand. I have not used any compass, therefore it is like this. So circle is with center O. O is the center of the circle. Next, this tangent xy is at the point of, it is through the point P. It is called as point of contact. P is called as the point of contact because xy tangent passes through the point P. So xy to the circle at the point P. Now what we have to prove? We have to prove that OP is perpendicular to xy. OP is the radius of the circle. XY is the tangent of the circle. Therefore OP is perpendicular. Perpendicular means here we have to get the 90 degree. For this we have to construct one construction is there. What is that? Take a point Q on xy. Let us take a point Q. Let us call it as Q. xy other than P. I have taken Q apart from the P. So Q is here, P is here. Then join OQ. I will join OQ. Now we have to prove that OP is perpendicular to xy and OQ is not the radius to the tangent because OP is the only tangent for the tangent xy at the point of contact P. We have to prove this. See now. Proof. For the proof, we have taken the Q other than the P and we have joined the OQ. And this Q lies outside the point, outside the circle because at this point only xy passes through the P. So if we take the point just neighbor to the P, then also this circle, the line will goes out of the circle. So when the line goes out of the circle, it will be longer than the OP. That's why I have written Q lies outside the circle. Therefore OQ is longer than OP. It is greater than OP in the length. What happens if Q lies inside the circle? See, I will take Q at this point. If I take Q in this point, OQ will not become radius, it will not become tangent or anything. What it will become? It will become a secant. So that is not required for us. Therefore, what we have to take? We have to take any point on the xy line because that is the tangent. And if we take any point other than P, then all the lines will be greater than OP. If I take here, then also. If I take here, then also. So when we take Q apart from the P, it will be longer than the OP. Therefore, the shortest distance here is OP. So when the shortest distance is OP, that should be perpendicular line. You know from the previous knowledge that the shortest distance from any 2 points, between any 2 points is the straight line, not the slant line. So shortest distance is OP and it is a straight line and it is perpendicular to the xy. Therefore, OQ will coincide with the OP. Therefore, OP is perpendicular to xy. This is about the theorem. See, in this theorem, the theorem states that the tangent is perpendicular to the radius at the point of contact. This should be, you have to remember these points. So to prove this, we have taken one point Q and that becomes greater than OP. Therefore, we say that OP is perpendicular to the XY. Okay.